Welcome everyone and thank you for joining us today. My name is Rupa. I am sustainability consultant at Turner and Townsend. Today we are joined by Julian Boss, principal consultant also working at Turner and Townsend. This is a retrofit information support and expertise event which is fully funded by Department of Energy Security and Net Zero, delivered by Turner and Townsend. Without further delay, I will hand over it to Julian to start today's presentation. Thank you.
Thanks, Rupa. Welcome, everybody. I'm Julian Boss, Principal Consultant with Turner & Townsend. Thanks for joining this session on PAS 2035, 2023. We'll kick off. This is going to be our agenda for the session. So just touching on these different parts of the PAS. I assume that with you joining this session, you're probably involved with a Warm Homes Social Housing Fund or level grants wave 3 retrofit project or something similar, whether as on the client side or within the supply chain. So obviously PAS 2035 is a big part of the delivery of that. Just a couple of sort of points really to start with. What does PAS stand for? Why do we call it PAS? It stands for Publicly Available Specification. In all intents and purposes, this is a standard, though technically it's a precursor to a standard, but everybody has been using this as the standard to which you must adhere if you're working on funded social housing retrofit projects. So there are various other standards apart from PAS 2035. 2030 is the standard for installers of retrofit measures on PAS 2035 projects. It's part of the PAS 2035 compliance is that the installers of the retrofit measures must be certified to PAS 2030, or MCS if it's for the installation of a low carbon technology. So that does cover heat pumps, but PV installations and the like as well. It does include, I think, battery storage now as well. What is the purpose of PAS 2035? As it says there, it aims to guide a holistic approach which considers the building as a system of elements, interfaces, and not forgetting occupants and occupant behaviour that interact, and that they're not just a set of elements that are independent of each other. So the purpose of it really is to look at that take that holistic approach and look at the kind of risks around that, and also look at the way you are delivering retrofit, which is compliant with PAS. So at the end of March this year, PAS, the latest version of PAS 2035, that's 2023, replaced the original version, and it is the only version which is now available after a transition period when both standards were available. But that finished on the 30th of March of this year, and so the 2019 version can no longer be applied to new projects. The requirements of PAS, you sort of simple pointers here. Any home receiving an install requires a whole dwelling assessment from a retrofit assessor. So if you're working on the bidding for funding through the government grant, you would have been able to just do a sample of the archetypes within your portfolio of property. But whenever you're doing an actual install, you will need an assessment of each property to which you're going to be doing an install. And that is part of the PAS requirement. So every completed dwelling requires basic monitoring, and some will require further monitoring. There's a requirement for retrofit advice to be delivered with every install, and that is the responsibility of the retrofit coordinator, whether they deliver it or they make sure someone who is qualified to deliver it does so, but there is a requirement that there is retrofit advice provided. A handover to the resident must be considered and provided where relevant. And that last point, PAS 2030, is the installer standard, which is required to comply with the PAS 2035 standard. And there is separate guidance for PAS 2030. Just a quick recap on the transition period, which, as I say, finished a month ago. The last version of the 2019 PAS was this one here, a bit of a mouthful. It was called 2019 plus A1 : 2022. That was still available for an 18-month period after the launch of the 2023 version. And there was this 18-month window when both versions were able to be used on projects. as I say, that finished on the 30th of March. So there are still some projects completing which are using the earlier standard. I think, in fact, that might have ended as well at the end of April. I think there was a window to the end of April when projects could still be finishing using that. So just moving on to retrofit assessment. So retrofit assessments undertaken by a qualified retrofit assessor or a coordinator, depending on the complexity of the assessment, and that is determined by things like heritage and non-standard building types. So where you might have higher levels of risk and maybe specialist knowledge requirements for the assessment of the building. So if the building is a listed building or in a conservation area, it doesn't necessarily mean that the building is complex because it's in a conservation area. But if it is listed, grade 1 or 2 or 2-star, then you would probably need a specialist retrofit assessor with the suitable heritage building qualification as well to be doing that. Otherwise, retrofit assessors and or coordinators should be able to complete a PAS 2035 retrofit assessment. As it says there, they don't need to be completed prior to a funding application. Generally, funding applications can be done with a sample of retrofit assessments, just looking at a sort of representative sample of the key archetypes of dwellings within the properties being included in the application. So retrofit assessments are really just collecting data. They're nothing to do with advice. They are purely looking at the condition of the property and gathering as accurate a picture as possible with which to inform the retrofit design. The assessment process and the design process, as it says at the bottom, can alter the assumptions made during a desktop exercise. So that's really meaning that the on-site assessment and the following subsequent design based on that assessment might be quite different to assumptions made by a client, an applicant for their funding, who might make an assessment that they want to do a kind of external wall insulation, lofts and or windows options for properties that they're going to be submitting. But actually an assessment might change that assumption, sometimes quite dramatically. Thinking about the retrofit design now. So the retrofit design document is really thinking about the design of measures. So if you have particular measures that are going to be installed, then you would want to know that those measures have been designed carefully for that particular installation. Certain measures do require accurate and detailed design, particularly around junctions where different elements meet, so roofs to walls, external walls meeting other external walls, and the kind of heat loss calculations around those junctions are important in order to minimize the risk of cold bridging, which really means there's a point in the fabric of the building where heat loss is greater than the surrounding area, and that encourages condensation and possibly mold development. So those kind of heat loss calculations and specific design are important to include, and they're also important to make sure that the design, when it's on site, actually gets built according to the design. Even with things like loft insulation, which a lot of people think is low cost, low risk, and indeed it is to a degree, but there are very sort of high risk elements to that. So if you have, for instance, downlighters in that top floor ceiling, they need to be capped off to make sure that they're not going to overheat when you have insulation wrapped over them. If there's any tanks and water storage pipe work in there, then that needs to be kept on the warm side of the envelope. So if it's a cold loft, then you need to wrap the insulation over tanks and pipes so that they don't stay on the cold side and then risk of freezing. And then you would obviously get, the leaks and flooding associated with freezing pipes in a loft. And the other thing to make sure about is things like fresh air ventilation in a cold loft space. So if you're installing a full 270 mil of loft insulation from eaves to eaves, you do maintain airflow. And there's some products which kind of create a sort of airflow channels that you can install the insulation right up to, and they're kind of a plastic fitting which maintains airflow across the eaves from side to side of the building. Details like that are really important, otherwise you do risk, again, poor airflow leads to condensation in the loft space, then possibly to rot of timbers in the roofs and things like that. So it might seem like it's a low cost, low risk installation, but proper design is really necessary. Ventilation design strategy needs to be adequate for the building, for the dwelling, and for the occupancy level. Obviously, depending on who the occupants are, there might be a greater or lesser degree of humidity and cooking odors, moisture, etc. So that needs to be taken into account. And also the intended outcomes. So what are the aims of the project to start off with? Are particular things being targeted? Like, is it maybe to do with an EPC value? Obviously, that's a target within these SHF and local grant funding schemes at the moment, but it might also include maybe organisational targets around fuel poverty, around obviously damp and mould, if that's an issue with particular properties or particular archetypes, and maybe other targets as well. So the design needs to bear in mind those intended aims of the project. Other things to think about, obviously, requirements for testing. So that might include air testing. So to understand what the background draft or air permeability of those dwellings are. Again, with particular buildings, particular estates that might be built with a non-standard build type, maybe a timber frame or some other kind of non-standard design, they might have inherent sort of issues around air permeability. So drafts because of construction design, and that might need to be very much incorporated in the retrofit design as well. Again, all these things need to be verified by the retrofit coordinator. We'll kind of come onto that in a little while. So just another quick bit about retrofit design. There's a tool within the PAS document, which is actually free to download from the BSI website, if you're not aware of that. PAS 20 and PAS 2030, PAS 2030, PAS 2035, 2023. You can download for free from BSI. Within the PAS, and I think it might actually be in PAS 2030, there is this measures interaction matrix, which basically is a visual aid to understanding which measures do not interact, which do interact, maybe which kind of contact physically, and in the red area, these are incompatible, as it says there on the left, there, the color coding. So just moving on to the PAS process, this is a kind of breakdown of the steps, if you like, through the retrofit process. And we can break it down into 6 kind of steps, and they roughly relate to sections of this sort of flow chart, really starting at the top with intended outcomes, moving on to, there's a kind of risk assessment stage, and that includes, here we've got a significance assessment, so that's what I was talking about in terms of traditional protected buildings. The dwelling assessment, and that also needs to look at ventilation requirements. The next step within maybe a retrofit coordinator sort of job is putting together an improvement option evaluation and a medium-term plan. So that's really looking at what are the options for the measures that you could install on that building, but given budgetary constraints and or other programs that you might be thinking of to do with the maintenance of social housing, then you would need to say, well, we're not going to be retrofitting to the maximum for this particular stage. We want to do it in stages as and when funding allows. And what are the stages which make sense and don't conflict? If we do certain measures now, we don't want to jeopardise possible future improvements later. And so that medium-term plan is going to provide that sort of a staged retrofit plan for us. Down at the bottom, once we've got our plan and design done, then you've got the installation, which is this dark box here, and all the sort of activities throughout. And that's followed by a monitoring and evaluation just to make sure that the retrofit measures are performing as designed. And if not, then you would need to move on to some more in-depth monitoring to understand if there are any issues. So just thinking about the first step, the intended outcomes, this is looking at the whole process from start to completion. So really the intended outcome is what you want to achieve is a particular EPC band. I mean, EPC band C is what the government funded programs are aiming at, but you might well as an organization have a more ambitious target than that. Not that funding will only allow for measures which are going to a C, but you as an organization might well want to achieve better than that. And that could be to do with lots of things. It could be to do with affordability. It could be to do with, long-term resilience, as in you want to go early higher performance because that's the way improvements are going to make more sense if you do a more ambitious one now. They could be relevant on the spend and the funding that you've got available, how many properties you're doing, etc., etc. There are other considerations that you might have are to do with the different archetypes that you have. Do you need to generate a plan for each property, or are there only 3 archetypes where a plan is likely to be suitable across a wide number of properties? And again, this is down to understanding, having really good data on your property portfolio, and that's always a good starting point for all retrofit projects. It's really looking at the quality of data that you've got and how you can analyze and scrutinize that to really inform your kind of retrofit program. It's important that the retrofit coordinator is really involved in this early stage as well and understand what the kind of background aims and objectives of the retrofit project are. So when thinking about risk assessment, there has been quite a change in PAS 2035, 2023. The previous version had a risk assessment which was based upon this idea of risk path A, B, or C, and that was measured against 5 criteria of the project. That was the number of dwellings, number of measures per dwelling, technical difficulty of the most difficult measure, if there's a particular combination of measures, as in the interaction matrix, whether that produced a kind of high level of risk, and the construction and build form. So as I said, certain measures are high risk, certain buildings are high risk, certain sizes of projects and combinations of measures are high risk, and vice versa as well. If you're just doing a small number of properties with low risk, under 5 properties with low risk measures, then that equally has a bearing on what the risk pathway would be. That was the approach in the previous version, but for the new version of PAS, they've standardised that process to just say there's a single sort of risk assessment, which was broadly in keeping with the risk path B of the earlier version. And the result is that you do a basic building assessment, but also with enough additional data to create an accurate RD SAP, or PHPP, that's Passive House Planning Package, energy model. And that's the energy model you would use to be assessing the kind of impact of proposed retrofit measures. So it's basically being able to have enough data to model with some degree of confidence what the different measures are going to achieve. That's just a little bit more. I won't do that. It's just a bit more about the old and new approaches on risk assessment. Step 3, the dwelling assessment. As I said, this is the retrofit assessment, and it's commissioned by the retrofit coordinator. They may well be doing the assessment themselves, but they also may be choosing a particular retrofit assessor to carry out that assessment. Basically, the assessment does kind of generate an EPC type energy model, if you like. Although because it's not lodged with the EPC register, it's not actually an official EPC. But as I say, every dwelling that's going to be retrofitted does need to be assessed. Repeating again that it is a data collection process only. You're really just understanding the condition of the building and anything relevant to the selection of measures, any underlying issues with the building, particularly to do with damp, whether that's penetrating damp from leaking rainwater pipes or poor pointing or damaged brickwork or rising damp or failed cavity wall insulation, any of these things which can be assessed, by that retrofit assessor going into the property would need to be dealt with before retrofit measures are installed, because they are a kind of, you need to establish a kind of good quality sort of fabric condition baseline before you start putting in retrofit measures, which might well reduce the air permeability of that structure, particularly if you're doing solid wall insulation or cavity wall insulation. Windows, doors, anything that's going to improve or reduce drafts and background ventilation. If you've already got underlying damp issues in the property, then they are really going to be exacerbated if you don't address them, and you do the retrofit works without addressing any underlying issues with moisture. Again, that's got to be signed off by the retrofit coordinator, so they would look at the retrofit assessment as provided by the retrofit assessor, and they would sign that off as compliant. So the next step is the planning and design stage. This also includes the improvement option evaluation. So you're reviewing proposed upgrades, looking at costs, levels of disruption for the particular residence that you have, all sorts of considerations. Maybe you need planning permission for a particular measure with, properties, whether they are historic or traditional or in conservation areas, etc., etc. And there are other these are the considerations you'll be doing at this stage. The medium-term improvement plan, as I say, that would give you the kind of staged approach going forward, the different measures that you might do at different stages depending on financing, etc. Also ensuring that appropriate design solutions are identified. That, as I say, it's very much based on who are your residents, are they vulnerable, elderly, young families, maybe other health conditions, etc., etc. You might be thinking that disruption to vulnerable communities that you have within the residential population that are looking at this retrofit really wouldn't be able to cope with certain measures. They'd be just too disruptive, and so your choices might well be heavily influenced by those considerations. It's also the case that you might well be thinking about resident engagement as part of that, and maybe thinking about the kind of initiatives that would help alleviate residents' worries about disruption. You might have plans for sort of a respite centre where people, elderly people who are staying at home normally a lot can go while works are going on. There might be a community centre or a library or some other place where actually you can set up a kind of respite centre during particularly disruptive part of the works to just help alleviate that for people who want it. There are all sorts of other ways you might be able to help in those situations, but it's very much a sort of, you need to be taking into consideration those sort of issues with your resident engagement officer and really understanding what kind of things would be appropriate. Coming on to the installation, installers, as I mentioned before, of all retrofit measures must be PAS 2030 certified for the specific measures that they're installing. There isn't just one certification that covers all different measures. You get certified for installing the measures for the different measures. Or as I mentioned before, if it's low carbon technologies such as PV panels or air source heat pumps, you would need to be MCS, that's micro generation certification scheme. You need to be MCS certified, again, for the technology to be installed, and the technology itself needs to be certified as well. That's to be compliant with PAS. Those certifications do need to be checked by the retrofit coordinator. That's part of their job. And the main role of the retrofit coordinator is to provide sort of oversight. Clerk of Works, a kind of project manager end to end, who really kind of has the oversight of everything, make sure it's being done in a compliant way, and that all the correct steps are being followed. Step 6 is the monitoring. So there are different levels, if you like, of monitoring depending on whether there are perceived issues. The basic monitoring would really be talking to residents, understanding that they're happy with an installation, they understand what's been installed, what changes have taken place, particularly with things like ventilation, heating controls. If you've got external or internal wall insulation, external particularly, knowing that there is a layer of insulation on the outside of the building and it is not very impact resistant, even with various coverings. If they're going to attach things to the outside wall, they need to be aware that certain fixtures and fittings need to be used in order not to damage that insulation. Ventilation is particularly important because generally when you've done a retrofit, you might well put in some sort of continuous ventilation. So a system or different individual room devices which run continually on a kind of background level, and then when moisture levels, humidity levels, or carbon dioxide measure levels raise to a certain amount, they will go onto a boost setting. So they'll come on as a normal extractor fan in a bathroom or kitchen would do when you switch the light on. But once that level has dropped down, they go back down to a background level. And as they're working on that background level, on a low tick over, as it were, it's not uncommon for residents to think that there's something wrong, that those ventilation systems shouldn't be on all the time, or that they're using energy that they can't afford. It's a very common thing. They use very, very little energy, but they do, they are essential to avoid damp and mold developing. And also you have to make sure that the gap between interconnecting, so bedrooms to corridors, hallways, etc. There's a chance for air to move between the rooms. So you basically specify the bottom of the doors need a 10mm gap between the door and the floor covering. I call it a door undercut, but that is there to allow that movement of air. So things like ventilation, things like heating controls, if new heating controls have been put in, and then making sure residents understand how to use those properly, and they're using them in a way which is going to help them with energy efficiency and costs of energy, etc. And also the other thing is just looking at energy bills. There's a basic kind of survey, if you like, and if there's any issues, if there's energy bills are higher than expected or usage is more than expected, then maybe a bit more deeper dig into what's going on and how the systems are being used, etc. There is an option, just a kind of a sort of intermediate monitoring there, where you might hand over to an independent retrofit coordinator to come in with a sort of fresh approach, and that might be because as a retrofit coordinator working in-house for an organisation, you might be a little bit too close to the project to be able to necessarily see potential issues. And that sort of advanced monitoring is what I was talking about, really, where you need to dig in deeper and start looking at how systems are working and get people to check, if there are particular issues that hadn't been initially realised. Coming on to the ventilation design. So we're particularly with the new PAS, all retrofits do need to have a ventilation strategy. It might involve things like air pressure testing or air tightness testing, which might be pulse testing or vacuum door testing or something like that, just to understand what the background uncontrolled ventilation is, what the level is. Anyway, so in terms of ventilation design, there's a few things to consider. The diagram here is giving a kind of simple sort of picture of the way that a centralized ventilation system might work. So you extract from the bathrooms and kitchens, So damp areas, so you're extracting that damp, moist, maybe with the kitchen odours, etc., bathrooms as well. And the extraction of air from those rooms draws fresh air in through triple vents in windows into living rooms and bedrooms, and then that moves through the house and is extracted with kitchens and bathrooms. Things to consider is really about the adequacy of the ventilation system, thinking about the proposed air tightness value of property post works. So after maybe solid wall insulation or doors or windows, they will affect the air tightness value of the property. Consideration of long-term property objectives and the occupancy of the property, both current and predicted. If it's a family home, even if maybe, you've got two elderly people in a property which could well be occupied by a young family at some point in the near future or later date, then you don't want to go back and start retrofitting different ventilation systems to cope with, different occupancy. So just thinking about the design briefly, I think about how this can affect your project. The measures, as I say, that would change air tightness of the property do need to be considered when thinking about the ventilation. So external solid wall insulation, internal solid wall insulation, new windows, floor insulation. So that's where you would maybe lift a suspended floor and timber floor and insulate between joists. That will increase the air tightness of the property quite considerably. So when you do that, as I mentioned, you're very likely to require some kind of continuous mechanical extract ventilation in the wet rooms and some sort of background ventilators, so correctly sized. And they can be a vent in the wall, or commonly they're trickle vents in windows, so a little sort of slot at the top of the windows with a small sort of plastic controller that can be moved across. Again, the temptation is for people to think, oh, I don't want to, lose all my warm air, and they can be tempted to switch off ventilation, but it makes such a big difference in terms of keeping damp and mold to a minimum, having that background ventilation going, and the improvements with the insulation, draft proofing, better windows, better doors, etc., will far outweigh any heat losses through improved ventilation. So you've probably heard of Trustmark and lodgement and that kind of side of PAS compliance. Trustmark is the kind of quality mark that has been nominated for the PAS. All the documentation for all the measures, including the guarantee information, needs to be lodged with them, which really means uploading it to the data warehouse. It's called Trustmark Lodgement, but it means it's basically, keeping and saving all the important documentation for that retrofit in a single place. That also includes things like retrofit coordinator and retrofit installer qualifications, and they need to be registered through a compliant Trustmark scheme provider. Trustmark itself doesn't register anybody. They're not a registration body, but what they do is that they have various kind of registered providers of training, etc. And those providers, they would do the registration of qualified assessors and coordinators and certified installers. So it's those providers who do the registration of the personnel with Trustmark. So for each project, you basically have a sort of file, if you like, a case file with Trustmark, and all that, as I say, all the important documents associated with that project. It is the responsibility of the retrofit coordinator to upload all the important documentation to the data warehouse, Trustmark data warehouse. Just a simple diagram of the lodgement process. So here we have the retrofit coordinator creating that project space, uploading a retrofit assessment. That the project requires an assessment. We have the retrofit assessor lodges the assessment, or the retrofit coordinator could create it if appropriate. It's accompanied by the RD SAP data. Certain requirements must be met before project ID can be generated. Defects in the property can be recorded, both assessment and mid-project. Designs must indicate who created them, which measures they cover, and what property defects are addressed. So again, it's kind of trying to keep an important detail about why certain actions are being taken, and those actions are being carried out by appropriate professionals. So competent installers, etc., and the measures themselves are as designed. So a project can be completed and lodged in stages. Each lodged stage can contain one or more measures. To complete a project, an updated the SAP, so that's a kind of EPC type of assessment must be provided. It's not an EPC, but it's all but name. That's it. Thank you very much. There's just a couple of pages here of other resources that you might well be interested in, relevant to obviously social housing, SHF Wave 3 funded projects and local grant funded projects. More broadly as well, there's all sorts of good resources in there to do with putting together teams, to do with governance, to do with resident engagement, finance, all sorts. These are some of the events coming up. There's a few of the on-demand resources that are also available. And the last slide is, as you've got QR codes, which will take you straight to a few of these resources as well.